Alright, so to start off this video about conservation of mechanical energy, let's just remember that the sum of the potential energy and the kinetic energies is mechanical energy. Right? Again, sometimes referred to as total energy. Right? And so sometimes we refer to this as total energy. Alright, and so mathematically, it's just going to be E equals K plus UG plus US. And I apologize, my K looks like an R. Alright, and so now in an ideal system with no form of friction, energy is transformed from potential energy to kinetic energy and vice versa. But the sum of the two is always going to be constant, right? It's not going to change. This means that mechanical energy is conserved in the absence of friction. Okay, and so when we always talk about in AP Physics 1, our systems are isolated, right? And so that's kind of like what an ideal system is, right? Is this concept of isolation, right? So no matter or no energy is going to be allowed to go in or out. And so the law of conservation of energy is represented mathematically as simply E before equals E after, which is simply saying that the total energy before is going to equal the total energy after. You can also say that the E, the total energy, is going to be a constant value. Okay, and so even further expanded, it's going to be K plus Ki plus UGI plus USI equals K final plus UG final plus USF final, USF, not University of South Florida, but spring potential energy final. Sometimes I put this as, KB, UGB, USB, but then when I get to the last part of USA, I just start chanting USA. Now, there are multiple ways to show the energies by using graphs. So one, on the AP test, they could do what are called, AP calls them LOL charts, right? Well, these two, the reason why is because these two are graphs, right? Which, if you look at the axis, will look like L's. And then this is just a system where you fill in what you have inside the system. Okay, and so when you do an LOL chart or LOL scenario here, you're going to use what are called, you're going to use bar graphs. Okay, and this is what College Board likes to use. Another way to represent energies is by using a pie chart. And this is what I personally like to use. But the size of the pie chart will represent the total energy, right? And so that'll represent that E value, and then the slices represent the individual energies. And so just here's a quick example. Sketch the energy graphs for an object falling from a height at 3 different locations. And we're going to say that we're dropping it, so our initial velocity will be 0. And so if this is my ground, right here are my 3 situations. So 1, I'll use a different color. So 1, 2, 3, right? And this will be H equals 0. Up here we say V equals 0. And so at the top in location 1, right, if I'm doing a pie chart, it's all going to be potential energy, right? Because it hasn't moved yet, so there's no kinetic energy. And so our system would only be the potential energy. If you do that as a graph, as a bar graph, right? Let's say I'm going to have 4 units, right? So all my potential energy units would be that, or my energy units would be with K. So on my bar graph, I'm going to have always have a total of 4 units. Okay. Now, if I'm at H equals 1/2 for position 2, right? So if my H, this is really sloppy, and I apologize. So if h equals 1/2 of the original height, that means now my energy is going to be half and half. So half of it's going to be kinetic, half of it's going to be potential. And so it is proportional. And so if I do that as a bar graph, if I have a total of 4, it's not U, it's K. Again, I apologize for the sloppiness. Okay, which means then it would have 2 potential and 2 kinetic units, right? And then finally, position 3, now we're all the way down at the ground, which means if I'm at the ground, for my pie chart, it's now all converted to kinetic energy. And then from our bar graph, right, oh, made that kind of big where I can't fit. So UG and K. So now we'd have all 4 of my units would go to the kinetic energy side. Again, the bar graphs is what AP likes. I personally like the pie charts just because of that visual, that this total, right? So now let's just look at a bunch of examples.